Okay, good morning to all of you. In this video, we are going to discuss one of the important topic belongs to BSc Physics and MSc Physics also. That is your particle confined in a rectangular 3D nano box, or it can be also said as particle confined in a 0D rectangular box or quantum dot. Okay, so here this is your rectangular box. Along x-axis length is your A, along y-axis length is B, along z-axis length is C, and a particle is confined in this box. That means particle could not be escaped from this box. And here we have been assumed that all the length are less than 100 nanometer. Then what will be the wave function? What will be the energy levels of the particle that we can expect, that we are going to discuss in detail. Okay, previously we have been discussed about one dimensional infinite rigid box or infinite deep potential well. You can find playlist of the quantum mechanics, that if a particle is moving only along x-axis and this length will be less than that of the 100 nanometer, and it could not be escaped along this side and along this side, then what will be the wave function and what will be the energy eigenvalues in detail we have been discussed in that video. I think part 1 and part 2 I have been done for this topic. You can for this topic, okay, you can check. Okay, in detail we have been discussed, and we found the energy eigen functions are this one, and energy eigenvalues are this one. Okay, in detail we have been discussed, you can check. And here, if we are going to consider a rectangular box, what will be the wave function of the particle or eigen function of this particle and corresponding eigenvalue, here I have been derived in detail, which will be helpful for your BSc exam and MSc exam. Okay, so let's start. I suggest to all of you, carefully you have to watch and write down the note. Consider a particle having mass m. This is the particle having mass m, is in dynamics in a rectangular box. This particle is in dynamics mode. Dynamics, okay, is in dynamics. As shown in figure, the sides of the rectangular box are A, B, and C along x, y, and z axis respectively. Here it is assumed that the dimension of each side is less than 100 nanometer. Okay, if it will too long, then particle can be easily move along x-axis. Suppose we are going to consider along x-axis is too long, not less than 100 nanometer, very greater than that of the 100 nanometer, I can say. So we can consider the particle is freely moving along x-axis. So for that case, different wave function and eigenvalues we can found. Here we are assumed that particle confined in a nano box or quantum dot, or you can say 0D rectangular box. Okay, that means confined in all the three directions. Okay, therefore this rectangular box will be called as quantum dot or 0D nanostructured material, right? In this case, the particle moving freely inside the box but could not escape from this box due to infinitely potentials of the walls. That means here I am going to show you that along x-axis the potential are infinite. So here you can say that at x equal to 0 and at x equal to a along x-axis the potentials are infinite. Along y-axis at x equal to 0 and at y equal to 0 and y equal to b also potentials are infinite. at 0 and z equal to c, potentials are infinite. So it is trapped inside this box, but it can be moved freely. That means there is no potential inside the box. Hence, mathematically, the potential can be represented as Vxyz, three-dimensional potential, will be equal to 0 from 0 to a, 0 to a. In between that range, potential is 0. From 0, that means from origin to B, also potential 0. Okay, from origin to C, also potential 0, and elsewhere it is infinite. Elsewhere infinite. That means just above A, or you can say at exactly A, it is infinite. Potential will be infinite. Exactly at B, potential infinite. Exactly at C, potential infinite. So particle is trapped in all the way. So hence it is called as the 0D nanostructure material or quantum dot. Okay. Now we have to write the time independent Schrodinger equation for the particle, because as we know that by solving the Schrodinger equation we can found the solution which will be represent the dynamics of the particle. So here we are going to write time independent Schrodinger equation. Okay, here we have to write the Schrodinger equation for inside the box only because as we know that particle could not be escape outside, so particle not to be present outside, so we are not going to be bothered about the outside dynamics, so not to be write Schrodinger equation outside. So inside we have to write Schrodinger equation inside the box only, because particle not exist outside the box, not exist outside the box. Okay, now TISC means time independent Schrodinger equation will be how much? We know that in general or in short, the time independent Schrodinger equation is H cap Hamiltonian operator upon the psi equal to E psi. Let this is your equation number 1, and this H cap is nothing but Hamiltonian operator, that is your kinetic energy plus potential energy, right? So here H cap is nothing but minus H cross square by 2m into del square plus Vr psi equal to E psi. So here Vr equal to 0 because we are writing the Schrodinger equation inside the box, as we defined that inside the box potential is 0 in all the way, so Vr will be 0. Hence this equation will be how much? Minus h cross square by 2m. Del square is nothing but del square by del x square plus del square by del y square plus del square by del z square psi equal to E psi. Here z I written small. Okay, here z is the small, here also small. Small z means I put a cross mark here. Okay, so capital Z means there is no cross mark. Whatever we are going to discuss later in this video, you just watch carefully. So that implies del square psi by del x square plus del square psi by del y square plus del square psi by del z square. This minus can be moved to this side, and this term will be moved this side. It will be minus 2m by h cross square E psi. So take this term to the left hand side, we can get del square psi by del x square plus del square psi by del y square plus del square psi by del z square plus this one 2m by h cross square E psi equal to 0. Let this is your equation number 2. Carefully you have to watch. Here I written small z. Okay, z, one cross is there. Here the particle is moving in 3D box, so the corresponding solution psi is the function of xyz. Okay, is the function of xyz. So psi is the function of x, y and z. This should be small, x, y and z, x, y and z. So psi will be x psi will be psi function of x, y, z. By considering separation variable method, this psi x, y, z can be written as separately x, which is the function of only x, y, capital Y, which is the function of only y, into capital Z, which is the function of z only. Let this is your equation number 1. These things we have been already discussed in our previous semester. By using separation variable method, psi xyz can be written as x capital X function of only x into capital Y function of only y into capital Z function of z. Let this is your equation number 3. Now we have to substitute this equation number 3 in equation number 2 here. So here you can see that the first term is your del square psi by del x square. So whenever I am going to put this psi value as x, y, z, so this is the differentiation with respect to x. So y and z will be act as constant, right? So you just put this one x into y into z, x, y, z here, here, here and here. So for this case yz will be constant. So yz del square capital X by del x square plus here xz will be constant because differentiation with respect to y. So xz into del square capital Y by del small y square plus xy, because here xy will be constant because differentiation with respect to z. So xy into del square z by del small z square. Okay, here this is your capital Z. Carefully you have to write your note. This is your capital Z and this is your small z. Z, one cross is there. Del z square plus 2m e by h cross square x capital X capital Y capital Z x y z equal to 0. Let this is your equation number 4. Okay. Now we have to follow the procedure of separation variable method, that we have to divide x, y, z, x into y into z with each terms. What we are going to get here, divided by x, y, z, we can find 1 by capital X into del square capital X by del small x square plus 1 by capital Y into del square capital Y by del small y square plus 1 by capital Z into del square capital Z by del small z square plus 2m e by h cross square, here xyz. So if I will be divide capital xyz, so got cancel, so only 2m e by h cross square equal to 0. Let this is your equation number 1. So here E represents the total energy, that means along x axis Ex plus along y axis Ey along z axis Ez. So here I written, but here E represents the total kinetic energy because potential energy inside the box is 0. So here E is purely kinetic energy. So along x-axis, so this kinetic energy E is the sum of along all the 3 directions. So Ex plus Ey plus Ez. Let this is your equation number 5a. Okay. Now, hence equation number 5 will be equation number 5. Here I am going to substitute instead of E, this one Ex plus Ey plus Ez. So equation number 5 will be how much? This one. Okay, equal to 0. So here I separated all the variables clearly. So this is the term belongs to only x, this is the term belongs to only y, this is the belongs to z, and here you can see 2m ex by h cross square, one term that is belongs to only x, function of x. So I have to put this 2m ex by h cross square nearby this term. So here you can see 1 by x del square x by del x square plus 2m ex by h cross square plus here one y term, here also y term will be there. So 1 by y del square y by del y square plus 2m ey by h cross square plus 1 by z del square capital Z by del small z square plus 2m ez, here z is small, okay, z by h cross square equal to 0. Let this is your equation number 6. The equation number 6 provides 3 independent equations. See, this is the function of only x, function of only y, function of only z will be equal to 0 only when this will be equal to 0, this will be equal to 0, this will be equal to 0 by the principle of separation variable method. So this equation number 6 will be give us 3 independent equations by considering separation variable method, that is this one will be equal to 0, right? So that implies here x multiplied with this one and with 0, so it will be del capital X del square capital X by del x square plus 2m ex by h cross square into x equal to 0. Let this is your equation number 7. Likewise, this will be equal to 0. So this will be equal to 0. Then just y multiplied with each term, capital Y. So del square capital Y by del y square. This is del y square. Del y square. Okay. Del y square plus 2m ey by h cross square capital Y equal to 0. Here this term will be equal to 0. That means del square capital Z by del small z square plus 2m ez by h cross square z equal to 0. Let this is your equation number 8 and this is your equation number 9. Okay. Now we have to consider this equation number 7 first. Consider equation number 7, that is your del square capital X by del small x square plus 2m ex by h cross square into capital X equal to 0. Remember, this x is in the subscript of e. So e subscript x. Do not write like this. This is wrong. Okay. Here ex. Okay. This is correct. So equal to 0. Now we have to put kx, here x also subscript, kx square equal to 2m ex by h cross square, 2m ex by h cross square. That implies kx will be equal to 2m ex by h cross square root over. Let this is your equation number 9a. Now if we have to put here as kx square, then it will be del square x by del x square plus kx square capital X equal to 0. Let this is your equation number 10. So now we have to solve. This is a second order differential equation. Now we have to solve this differential equation. We know very well how to solve it. Consider the auxiliary equation of equation number 10. That is your m square plus kx square equal to 0. M will be equal to plus or minus I kx. So hence the solution of this differential equation will be x will be equal to a e to the I kxx plus b e to the minus I kxx, okay, kxx, you just write kxx, mistakenly written. This is your kxx, right? So if we are going to consider, this is your e to the power I kxx, that is nothing but your how much? This will be cos e to the I kxx will be cos kxx plus I sin kxx. Here e to the minus I kxx. That means e to the minus I kxx will be equal to cos kxx minus I sin kxx. Okay. So here is the constant a is there, constant b is there. So if you have to solve further, then you are going to get c cos kxx plus d sin kxx. See, here I written that a e to the I kxx plus b e to the minus I kxx. So this can be written as cos kx x plus I sin kxx plus b into cos kxx minus I sin kxx. So here a cos kxx plus b cos kxx. So a plus b cos kxx plus here a I or ia minus here ib sin kxx. So let a plus b is your c. This is another constant d, whatever written here. See, so finding the solution of this differential equation is a familiar for us. Okay, so the solution of this equation number 10, we found that c into cos kx x plus d sin kx x. Let this is your equation number 11. Okay, now to find the constant, we have to consider the boundary condition along x-axis, because this differential equation represents the dynamics along x-axis. So along x-axis, what is the boundary condition, or what are the boundary condition we have to consider to find the c and d. So we have to consider the figure, then we can found that at x equal to 0, at x equal to a, this is your x equal to 0 and this is your x equal to a. So as here infinite potential is there, at x equal to a also infinite potential is there, so particle not to be exist. So the wave function or the existence, psi is represent the wave function of this particle or existence of this particle. Okay, so if here at x equal to a and x equal to 0, we have the infinite potential or infinite repulsion, you can say infinite repulsion, then at x equal to a and x equal to 0, the particle not to be exist. So the boundary condition, in this way we can write that x at x equal to 0 equal to x, this value at x equal to a will be equal to 0, right? First we have to consider this one. At x equal to 0, we have to put in the equation number 11. Hence equation number 11 will be, first we have to consider this one. So this value will be 0, will be equal to c into cos, here at x equal to 0, that means cos 0 will be 1. So c, here sin 0, that means sin 0 will be 0, so d into 0. So here we found c equal to 0. By considering the first boundary condition, that means x will be 0 at x equal to 0. Okay, by considering this boundary condition, we found c value is 0. Now we have to put c value here, then the modified solution, that means the modified equation number 11 will be x equal to d into sin kx x, right? Same thing I have written. Now equation number 11 will be x equal to d sin kx x. Then we have to consider another boundary condition, that x will be equal to 0 at x equal to a. Here this is x equal to, okay, no need to write. So x or the so-called solution or the so-called wave function will be equal to 0 at x equal to a. So here I told to you that the wave function, that means the wave function belongs to a function of xyz. If we are going to consider along x-axis, the so-called wave function is capital X. Okay, so this capital X represents the wave function along x-axis. So at x equal to 0, this value equal to 0. At x equal to a, capital X also 0. So by considering at x equal to 0 or at origin, capital X will be 0, we found c will be equal to 0, c will be 0. And now we have to consider at x equal to a, this capital X or the wave function will be 0. Then what we are going to find out, check here. So now consider the boundary condition, that is this one, that this value will be equal to 0, that equal to d into sin kx. Here instead of x, what we have to write, a. Okay, so that implies sin kx a equal to 0, because d is a constant not to be 0. If I will put d will be 0, that means whole wave function will be 0, which could not be acceptable. So we have to consider sin kx a equal to 0 and d not to be 0. So this value will be 0 when kxa will be nx pi, or n pi you can consider n pi. So this sin kxa will be 0 when, that means kxa will be nx pi. So for all pi values, this n is represents 1, 2, 3 and so on, except 0 value. Except 0 value, we can consider n values are 1, 2, 3, 4 and so on. So for all the pi value, this sin kxa will be equal to 0. So hence kxa will be equal to nx pi. That implies kx will be nx pi by a. Let this is your equation number 12. So here nx not to be 0 because 0 not acceptable. Why not acceptable? That I am going to be discussed here. If we are going to consider nx will be 0, then what will be the problem will happen for solving the wave function? That I am going to be discussed here. You just wait. So instead nx equal to 0, all the integers, all the positive integers will be considered. Okay, so kx will be nx pi by a. So hence the general solution will be, that means this one, x will be equal to d sine, instead of kx, what we have to write, nx pi by a, nx pi by a into x. Let this is your equation number 13, right? So this equation number 13 represents wave function along x-axis, right? Similarly, by applying boundary conditions y equal to 0, y equal to 0 at x, y equal to 0 and y equal to b. So capital Y equal to 0, capital Y equal to 0 at y equal to 0 and y equal to b. Similarly, z, capital Z, z equal to 0 at z equal to 0 and z equal to c. These are the two boundary conditions. Not two here, one boundary condition, four boundary conditions. Y will be equal to 0 at y equal to 0, y will be equal to 0 at y equal to b, z equal to 0 at z equal to 0, capital Z equal to 0 at z equal to c. Okay, so here 0 is the coordinate and here 0 is the value, not to be confused. Okay, so if we are going to apply these boundary conditions on the solutions of 8 and 9, we have the solutions here as equation number 8 and 9. If I am going to apply these boundary conditions on 8 and 9 as I have been applied on 7, then what we are going to be found out? We can found that ky, here we found kx equal to nx pi by a. Here we can found ky will be equal to ny pi by b. Let this is your equation number 14. So if we have to put ky in the general solution along y axis, we can found here x along x axis we found d into sine nx pi by a into x. Similarly, y, capital Y, or the wave function along y axis will be some constant. Let this is capital E into sine ny pi by b into y. Let this is your equation number 15. Similarly, along z axis we can found kz equal to nz pi by c. Let this is your equation number 16. And z, capital Z, that means wave function along z axis will be equal to some constant capital F into sine nz pi z, here small z, by c. Let this is your equation number 17. So along x-axis we found the wave function, this one. Along y-axis the wave function, this one. Along z-axis wave function, this one. Okay. Now by considering normalization condition for 13, 15 and 17, that is your what? 0 to a. Along x-axis 0 to a x star x dx, or along y-axis 0 to b y star y dy, or along z-axis 0 to c z star z dz equal to 1. Sorry, normalization condition means equal to 1. You have to write equal to 1. This is equal to 1. That means if I am going to consider along x-axis, the so-called normalization condition along x-axis, if this is my wave function along x-axis, the normalization condition will be tell that x star x along x-axis, that means 0 to a, has to be 1, right? Similarly, along y-axis will be, this one will be 1, this one will be 1. By considering this one, x star x dx will be 1, 0 to a, we can found the constant, this one, normalization constant, this d is nothing but called as your normalization condition. This is d, okay? This is your d, capital D. This is the normalization constant. We can found that 2 by a root over. Here I not derived because we have to represent this topic in our exam in the limited time and limited page. So as we know, this is the general for us. By considering normalization condition, we can found d equal to 2 by a root over. So here I not derived those things, but if you want to know how it will be, you can refer this one, okay? When we have been discussed one-dimensional infinite rigid box only along x-axis, there I have been derived that here we found that psi n x equal to b sine n pi x by l, and by considering normalization condition, this one, here, by considering normalization condition psi n star psi n dx equal to 1, we found b equal to 2 by l root over. So here l is the length. L is the length along x-axis of the box, that is 0 to L, length is x. But here in our case, here for this problem, along x-axis we have been taken the length as a. So obviously if I will be consider this normalization condition, so we can found d will be equal to 2 by a root over. Similarly, e will be 2 by b root over, and f will be 2 by c root over. Okay, so hence the equations 13, 15, 17 will be this one, 13, 15 and 17 will be capital X equal to 2 by a root over into sine nx pi x by a. Let this is your equation number 18. Capital Y, which is the function of only y, or you can say wave function along y-axis, root over of 2 by b into sine ny pi y by b. Let this is your equation number 19. Z, wave function along z axis, 2 by c whole root over into sine nz pi small z by c. Here this is small z, okay? This is capital Z. Whenever I retain the small z, I just put it one line in the middle, okay? To differentiate, this is the small, this is the capital, right? You do so. Let this is your equation number 20, and as I told that nx will be 1, 2, 3 and so on, not to be 0. Why not to be 0, I am going to discuss, you just wait. And likewise ny will be equal to 1, 2, 3 and so on. Nz will be nz, here z is the small, so I have to put a mark, 1, 2, 3 and so on. So here nx, ny, nz are called quantum numbers. By using the quantum numbers, we can found the various energy levels or energy states, right? So we have to move towards the general expression or general wave function of the particle. Here we found along x-axis wave function, along y-axis wave function, along z-axis wave function. But the particle is in the dynamics inside this box. Inside this box, particle is in dynamics. So in general, the solution of the difference of that particle which is in the dynamics in this 3D box, that is your this one psi xyz, which is equal to capital X into capital Y into capital Z. So here separately we have been solved, and we found that x equal this one, y equal this one, z equal this one. So hence therefore the general solution for the particle will be this value we have to put, this value we have to put, this value we have to put. So now we have to put this 18, 19, 20 equations in equation number 3. What we can get? Here I written that therefore the general solution of the particle in 3D box, that is equation number 3, will be psi xyz will be equal to capital X. I shown you that capital X into capital Y into capital Z equal to psi xyz equal to this one. This is the equation number 3. So here instead of x we have to put this one, 2 by a root over of 2 by a sine nx pi x by a. This is y, 2 by b root over sine ny pi y by b, and z is root over of 2 by c sine nz pi z by c. Okay, so this is nothing but called as your wave function or normalized wave function. So here I am going to simplify somewhat. Here 2 by a, 2 by b, 2 by c taken to the initial, 2 by a, 2 by b, 2 by c, root over of 2 by a, root over of 2 by b, root over of 2 by c, sine nx pi x by a, sine ny pi y by b, sine nz pi z by c. Let this is your equation number 21. This equation represents normalized wave function, or you can say eigenfunction of a particle which is trapped. Trapped means not to be escaped in a 3D rectangular box. So here 3D rectangular box dimension is nano. Okay, 3D rectangular box or quantum dot, right? So this is the general form of the wave function of a particle which is trapped in a rectangular box, right? So here I written by considering a note, you have to write that, see here nx, ny, nz, what I told that these are represents the quantum numbers. So now either nx or ny or nz you just put 0. So here if I will consider 0, then wave function will be total 0, because this term will be 0 and total whole wave function will be 0. That means what? That represents the physical meaning of psi xyz will be 0 by considering, here I written clearly, nx or ny or nz could not be 0. If we take 0 then this one psi xyz equal to 0. That means particle not inside the box. If psi xyz will be 0, that means there is no information regarding particle inside the box, or we can say that the particle not inside the box, which not to be acceptable, because already we have been defined that potential is infinite at the boundaries of the rectangular box, so particle not to be escaped. So if I am going to put nx or ny, nz will be 0, that is giving that particle not to be exist inside this box. So hence nx or ny or nz could not be considered as 0, but above 0 all the integers will be considered. Okay, 1, 2, 3 and so on can be considered. By considering 1, 2, 3 for nx, ny, nz, we can get different energy states or quantum states of the particle which is trapped or confined in a rectangular box. Now we have to find out energy eigenvalues. That I put a heading that evaluation of energy eigenvalues. For that we have to consider first equation number 12. Here this is the equation number 12. This is equation number 12. Here kx equal to nx pi by a. Okay, consider that one, kx equal to nx pi by a. Already we defined that, or we initially we have been considered that kx square equal to 2m ex by h cross square. So kx square will be nx square pi square by a square. So kx square is nothing but is your 2m ex by h cross square. Okay, by considering equation number 9a, you can consider that the equation number 9a represents this one, right? Kx square equal to 2m ex by h cross square. So I have been substituted over here. So that implies I can write ex will be nx square pi square h cross square will be multiplied with this numerator divided by 2m, so 2m a square. Okay, I can write ex, but why I written nx? Because as here nx is there, so each value of nx we can found the energy value, then so that I have been written that E nx. That means for each nx value, I can get one energy value, right? So here E nx, how it has been written? This is E n x is subscript for n. Okay, x is subscript for n. Clear? So E nx will be equal to nx square pi square h cross square by 2m a square. Let this is your equation number 20. So here you should not be confused that some books they have been written instead of h cross square h square. As we know that the reduced Planck's constant h cross is your h by 2 pi. So if we are going to write here instead of h cross h by 2 pi, this will be h cross square will be how much? Will be h square by 4 pi square, right? By 4 pi square. So if I will be put instead of h cross square as h square by 4 pi square, here h square by 4 pi square. So pi square will be got cancelled, and we found nx square h square, not h cross, h square by here 4 into 2 8 m a square. So either way you have to remember, you can remember this format, or you can remember that E nx equal to nx square h square by 8m a square. Because if I'm going to put instead of h cross square as h square by 4 pi square, so pi square will be got cancelled, and this will be the value. So either format you can remember. So I suggest that you remember in this format. Okay, so here nx equal to 1 2 3 and so on. Similarly, using equation number 14 and 16. 14 is where this one. Here 12 is represents kx equal to nx pi by a. Here 14 ny pi by b. 16 nz pi by c. So by using 14 and 16, we can get eny equal to ny square pi square h cross, or h cot, you can say h cot or h cross. Okay, h cross is there, h cross square by 2m b square. Let this is your equation number 23. Ny equal to 1 2 3 and so on. enz equal to nz square pi square h cot square or h cross square by 2m c square. Let this is your equation number 24. nz here 1 2 3 and so on. Now as we know that total energy is your sum of ex, ey and ez, and here we found along x-axis the energy is this one, along y-axis energy is this one, along z-axis in general energy along x-axis, y-axis and z-axis. So total energy of the particle inside the rectangular box will be sum of these three. Now the total energy will be, that is equation number 5. This is your equation number 5, right? 5a, sorry, this is your equation number 5a. okay, will be Enx, Eny, Enz, or this is total energy. Okay, that is called this much plus this. Okay, so this is your total energy. Uh, Somewhat we have to simplify that 1 by 2m pi square h cross square, common for all the three terms I taken to the initial. So E nx ny nz equal to pi square h cross square by 2m into whole into nx square by a square plus ny square by b square plus nz square by c square. Let this is your equation number 25. So here this equation 25 represents the total energy for a particular energy state. Okay, and the particular energy state can be evaluated by considering various values of nx, ny, nz by combinations of nx, ny, nz. Okay, as I told that nx, ny, nz will be starts from 1 1 1. So here if I am going to put 1 1 1, then I am going to find out the ground state energy of that particle. Okay, so so this is the this equation represents the general form of total energy. Okay, here nx, ny, nz are called quantum numbers which are required to describe each stationary state or evaluate or finding each stationary state. Nx will be 1 2 3 and so on, ny also 1 2 3 and so on, nz small z, okay, 1 2 3 and so on. Okay, now we are going to consider a special case. Here we considered the rectangular box having sides are a b c along x y z axis. This is a rectangular box. If I will consider this is a cubical box, that means all the sides are equal. Let all the sides are equal a, along x axis a, along y axis a, along z axis also a. So like this, if we have to consider a cube or cubic box, for cubic box a equal to b equal to c, let this is your a. Okay, hence the wave function will be, wave function here we found that this one. So here the wave function for the cubic box will be, instead of b I can write a, instead of c I can write a. So this will be how much? Here you can see 2 into 2 into 2 8. This will be a into a into a cube. That will be 8 by a cube whole root over of 8 by a cube, into sine nx pi x by a into sine ny pi y by a into sine nz pi z by a. Here you just write by considering the equation number 21. Okay, considering equation 21, you just write this one, right? So we found the general wave equation or wave function of the particle which is trapped in a cubic box is this one. The corresponding eigenvalues or total energy will be how much? Here instead of instead of b we have to write a, instead of c we have to write a. So this will be a square taken outside. So pi square h cross square by 2m a square into n x square plus n y square plus n z square. So this is the corresponding eigenvalues for each and every quantum numbers for a particle which is trapped in a cubical box. This is a special case. Okay, so up to this much you have to write in your exam. So maybe you are going to be confused that this much so long, that how we are going to be represent in our exam this long question, uh, coming for 8 marks and 10 marks. So how you have to maintain your representation in your exam, I am going to be suggest you just wait. So here we have to stop our today's discussion. In our next discussion, we are going to next class we are going to discuss degeneracy of energy states. Okay, so here one example I given that from the above energy eigenvalue expression, we can found the lowest possible energy of the particle for this one, for this case, for cubic case I am considering for lowest energy value, lowest possible energy, that is the energy in the ground state or fast level, you can say energy of the ground state or fast energy level. Fast energy level, ground state or the fast energy level will be how much. Here we have to consider nx equal to 1, ny will be 1, nz will be 1. So this will be 1 1 1 will be 1 plus 1 3 pi square h cross square by 2m a square. Similarly, if we are going to consider for rectangular box, it will be how much, 1 by a square plus 1 by b square plus 1 by c square, right? So considering the cubic box, we have to discuss degeneracy of energy state, that we are going to discuss in our next class. So here I am going to suggest that how we are going to represent, you are going to represent this long question in your exam. You just watch. See, whatever written here, you can squeeze it. You can write 2 or 3 lines and you draw this figure. Here you can reduce the writing, and here I written many steps. So you have to write this one, this step, and this step. Okay. So by considering separation value variable, you just write this one. So up to these 3 steps you have to write. Okay. Then uh, you have to write equation number 6. So from the equation number 6, no need to write these things. You have to write this. Okay. So by considering equation number 7, you can write like this. Now consider equation number 7 and kx square equal this much, and the solution of this equation number 10 will be this one direct. No need to write these steps. These steps are common. Okay, common steps, no need to write. For your understanding purposes I written that you have to write. And then boundary condition along x-axis is this one, and along y axis this one, along z axis this one. So direct you can write by considering boundary conditions along x and y and z axis. We can found kx equal to this one, ky equal to this one, kz equal to this one. So hence x will be this one, y will be this one, z will be this one. So in all the steps, like these are the steps, whatever I written, no need to write in your exam. I am telling you, in your exam no need to write. Okay. Now, so by normalization condition we can found d e f will be this much. So hence x will be this much, y z you have to write, and general solution will be this one. So by considering kx square equal to this one, e and x will be this one, and e and y, e and z, that means extra 1 or 2 lines whatever I written, this note, that whatever I written no need to write, and extra 1 or 2 lines, this step no need to write, direct consider this one. Sorry, this step no need to write, consider this one. That implies this one, e and x will be this one. Similarly, e and y, e and z we can found this. So hence a total energy will be this one. So by simplify we can get this one. So if we are going to reduce in this way, how many pages I written the note? 1 2 3 4 and 5 and 6 pages notes. in my handwriting, you can see that the writing is somewhat larger letter. So if you are write small letter, generally you are writing, so it will be 2.5 page or maximum 3 page. In between 3 pages you can complete uh, the answer of this question. So in your exam, this will be the long question. It will ask as like this, that you have to find out the energy eigenfunction and eigenvalues of the particle which is trapped in a 3D rectangular box, or discuss quantum dot, or particle confined in a 0D rectangular box. So by any uh, language in your exam you can found the question. Okay, so all the three question are same. So carefully you have to watch this video, write down the note, prepare for your exam, and in next class we are going to discuss degeneracy of energy state. So thank you so much for watching this video, and you can download this note. I given the link in the description. Okay, the detailed note whatever we have been discussed, and here I done some corrections. PDF format you can download from the description. I given the link. Okay, so thank you so much for watching this video. Thank you.